You know, for the longest time, we humans thought we had a pretty good handle on reality. We figured it was simple, solid, predictable. But then, over the last 100 years or so, science came along and just tore that picture to shreds, revealing a universe that's so much stranger and more mysterious than we ever imagined. So, let me ask you something right off the bat. The world you see around you, the chair you're sitting on, the air you're breathing, is any of it actually real? As we're about to find out, the answer, well, it's way weirder than you probably think.
To really get a grip on how wild things have gotten, we first need to take a step back. So let's go back to a simpler time. Welcome to the clockwork universe, a world of beautiful, predictable, and simple certainty.
On one side, you've got the universe as Isaac Newton saw it, this perfect, predictable machine, kind of like a giant clock. Space and time were absolute. They were the unbending stage. But on the other side, you have the new reality science has uncovered, this completely mind-bending world run by probabilities, where space, time, and matter are all relative and tangled up together. So what happened? Well, right around the turn of the 20th century, scientists started noticing things, cracks in this perfect Newtonian machine. And these weren't just little cracks. No, these were deep fractures that were about to shatter everything we thought we knew for sure. All right, this is where the real fun starts. We're going to go on a little cosmic zoom, and our first stop is straight down the rabbit hole. We are zooming way into the bizarre and unpredictable world of the quantum. And trust me, it gets weird. Okay, look at this. This painting is a perfect way to think about it. From far away, it looks like a solid, smooth image, right? But if you get right up to it, you see it's just dots, thousands of tiny separate dots. Well, believe it or not, our so-called solid world is exactly like that. It completely dissolves into these little discrete points, atoms, once you look close enough. And once you get down to the level of those dots, things get incredibly strange. The first rule of the quantum club is something called superposition. Now, this is the part that just breaks your brain. It says a particle, like an electron, isn't in any one specific place. Nope, it exists in all of its possible states at the exact same time. That is, until the moment you decide to look at it. So, what's the big takeaway here? It's that the world of the super tiny is built on a foundation of pure, unadulterated weirdness. Particles are just a haze of possibilities. And get this, the very act of observing something is what forces it to become real. So that solid, dependable world you think you're living in, yeah, it's actually built on a bedrock of pure uncertainty. How crazy is that? All right, take a deep breath. We're zooming back out now, way out. From the tiniest things imaginable, we're heading to the biggest things in the cosmos to see how Albert Einstein completely blew up our ideas of space and time. It all started with what Einstein himself called his happiest thought. Just picture this. He imagined he was falling, say, in an elevator. For that moment, you're in free fall, you'd feel totally weightless, right? It's like gravity just switched off. And that's when it hit him. The feeling of gravity is basically the same thing as the feeling of acceleration. And this one simple idea, man, it wasn't just a new theory of gravity. It was about to rewrite the entire rule book for the universe. So if gravity and acceleration are basically two sides of the same coin, then gravity isn't some invisible force like Newton thought. And that led Einstein to this absolutely stunning conclusion. Space and time, they're not just some empty, boring stage where things happen. No. They are a single, dynamic, flexible fabric, a thing he called space-time. So if space-time is a fabric, then what's gravity? Well, this classic analogy nails it. Gravity isn't a force pulling you down. It's just what happens when mass and energy bend or curve space-time. Think of a bowling ball on a trampoline. It makes a big dent, right? Now, if you roll a little marble nearby, it doesn't get pulled by the ball. It's just following the curve in the fabric that the ball created. That's gravity. And this new way of seeing gravity had some seriously huge consequences. Check out this timeline. It starts in 1915, when Einstein's own math told him the universe probably wasn't just sitting still. Then jump to 1929, an astronomer named Edwin Hubble actually sees it. He observes that galaxies are rushing away from us. The whole universe is expanding. And the final piece of the puzzle came in 1965, when scientists found this faint microwave glow all over the sky, like a fossil, the leftover heat from the very beginning. The conclusion was just inescapable.
Our entire universe, everything we know, began in one single massive event, the Big Bang.
Okay, so at this point, we've got a new picture of reality. It's weird, for sure, with quantum uncertainty and warped spacetime, but it feels kind of complete, right? Well, the story is far from over, because now we get to the final, biggest reveal of all, the unseen universe. You know, after figuring out quantum mechanics and relativity, you'd think we'd have a pretty good idea of what the universe is made of. We thought we did, and we were wrong. I mean, profoundly, shockingly wrong. Just take a look at this. This chart shows what everything is really made of. You see that tiny little sliver, the 5%? That's what we call normal matter. That's all the stars, all the planets, all the galaxies, you, me, everything we can see and touch. Just 5%. The rest? It's made of two things we know next to nothing about: dark matter and dark energy. So, what the heck are these things? Well, the crazy part is, we only know what they do. We know dark matter is out there because we see its gravity. It's like this invisible cosmic scaffolding that holds entire galaxies together. Then there's dark energy, which is even weirder. It's some kind of mysterious energy that's pushing everything apart, making the universe expand faster and faster. But as for what they actually are, honestly, we have no clue. It's a complete mystery. Let that number just sink in for a second. 95%. 95% of our reality is made of stuff we can't see, we can't touch, and we fundamentally do not understand. Which brings us all the way back to where we started. But now, wow, things look different. So let's ask it again. What is reality anyway? Let's try to paint this new, bizarre picture. Is it a world where solid matter isn't really solid at all? Where it might just be a statistical illusion? A wave of possibilities that only snaps into focus when we happen to look at it? Is it a universe where time isn't some steady clock ticking the same for everyone, but something that can stretch and shrink, something that's literally woven together with the very fabric of space? And is it a reality where, maybe most humbling of all, a staggering 95% of the cosmos is completely hidden from us, right here in plain sight? Look, if this all feels deeply strange and counterintuitive, there's a really good reason for that. Our brains, our common sense, didn't evolve to understand quantum physics or the Big Bang. Our intuition evolved for one simple reason: to help us find food and not get eaten here on planet Earth. It was never built to grasp the true, mind-bending nature of the cosmos. I want to leave you with this incredible quote from Hermann Minkowski. He was one of Einstein's teachers, and he saw where all this was heading more than a century ago. He said, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows." And I think what all of modern science is telling us is that we're still just beginning to peer beyond those shadows, trying to get a glimpse of the true, independent reality that's been waiting there all along.